Determine how many roots the quadratic equation has and whether the parabola will open up or down. This equation is already in standard form, and we can notice that the a term, the leading coefficient, is 1. Since it's positive, it will open up. Let's write down the discriminant, evaluate, and the discriminant is 28. Since this is positive, we know we're going to have two real solutions. Therefore, the parabola will open up, having two real solutions. An example could look like this. Another example, it could look like this. Another example, it could look like this. Remember, the parabola has two arrowheads. These two arrowheads will extend indefinitely and eventually will cross the x-axis. This is not the actual graph of this quadratic equation, but a representation of how the graph could look using these two factors, that it opens up and has two real roots. When we take a look at this graph, we can see that we have two real roots. Therefore, the discriminant has to be greater than 0. The discriminant is positive. Since the parabola opens up, we know that the a term, the leading coefficient, is positive. The coordinates for the vertex is 2, -4. Remember, this is going in increments of 2. So the 2 and down -2, down -4. The vertex, since it's the lowest point on this graph, it is a minimum point. The axis symmetry is the vertical line that divides the parabola into two symmetrical parts. The equation for this line is x equals 1. Our x-intercepts are where the graph crosses the x-axis. So the coordinate for the first one is 0, 0, and the coordinate for the second one is 4, 0. Let's graph the function g of x is equal to -2x squared plus 10 and compare it to its parent function f of x is equal to x squared. Since we do not have a b term, our axis of symmetry is x equals 0. Let's substitute 0 into the function. G of 0 is equal to 10. Our vertex is 0, 10. For my domain, I'll increase in increments of 1, and I will use my step pattern. Since my leading coefficient is -2, my step pattern, I will multiply -2 times 1 times 3 times 5 times 7. So therefore, from 10, all I have to do is subtract 2. That will leave me with 8. From 8, I have to subtract 6. That will leave me with 2. From 2, I will subtract 10. That will be -8. And from -8, I'll subtract 14. And that would be -22. For f of x, I'll just do mental math. 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. A lot of times I prefer to check my last term, but you could always use this. Instead of using the step pattern, you'll just plug in your domain values. I will plug in the domain value of 4. G of 4 is equal to -22. So the point is 4, -22. Let's compare g of x to f of x. We have a reflection across the x-axis, a vertical translation up 10 units, and a vertical stretch by a scale factor of 2. The graph G is a reflection across the x-axis, a vertical translation 10 units, and a vertical stretch by a scale factor of 2.